So we started this unit exploring the concept of balance with some of these visual examples. So I want to go back to this question where we're talking about a geologist and he's got rocks that all weigh 1 pound each. And then we've got different boxes, and we're told in this problem that each box has the same amount of rocks in it. So if there's 2 in this one, then there's going to be 2 in all of them. So basically what we're trying to do here is we're trying to figure out how many rocks are in each box while keeping the balance on this scale. So a lot of us looked at this problem and we thought, okay, well there's 2 rocks on this side that match up with 2 rocks on this side, so why don't we take those away? Which I thought was a great idea. And then we get to kind of an interesting problem. We've got boxes on the left-hand side and boxes on the right-hand side. But if we know that there's the same amount of rocks in each box, then whatever's in here will perfectly match whatever's in there. So we're also allowed to take boxes off of the scale, not just rocks. And once we do that, we're left with 1 box equal to these 2 rocks, which means there's got to be 2 rocks in each of them. So let's see how this applies to equations. So obviously it looks a little bit different, but now that we've been talking about equations for long enough, you kind of get the idea of drawing a line down. When you see normal numbers like this, I want you to think about those being the individual rocks on the scale. So it looks like we've got rocks on the right side, rocks on the left side. When you see something attached to a variable, I want you to think about this as our boxes. So to me, this says we have 4 boxes on the left-hand side. We have 6 boxes on the right-hand side. So I'm actually going to start by eliminating some boxes because I know that whatever's in this box on the left-hand side matches perfectly with this box. Take away this box means I can take away this box. Take away this box means I can take away this one. And last but certainly not least, we're left with 2 boxes on the right-hand side. How I'm going to show that algebraically is, since this is a positive 4x, I'm going to take away or subtract 4 of the boxes. So that's no different than me just canceling out those boxes so that I'm only looking at the rocks. Looks like I have 3 left over here. We said we anticipated 2 boxes over here, and minus 11 hasn't changed. Once I do that, now I'm really just thinking about solving these problems like normal, as in we don't know what x is, which means we don't know 2 of those x's are, but I do know what 11 is. It's a number, so I'm going to do the opposite. The opposite of minus 11 is to add 11 both sides. Last but certainly not least, the 2 and the x are being multiplied, so I need to divide by 2. If I take a moment and I check my answer, I'm using my answer of 7 on both parts of my equation. And I'm checking to make sure, did I actually get it right? So on both sides of the equation, I have to follow GEMS. So 4 times 7 would be 28. 28 plus 3 is 31. 6 times 7 would be 42. 42 minus 11 would be 31. Looks like our answer checked out.